All right, let's look at the 2018 polar question. That was number 5, so that means without calculator. So let's kind of break this one down, see how to do this one without a calculator sitting in our hand. And it always, to me, boils down to, do you understand how the curve is being built? And I'm going to kind of mark this up and kind of show you how to kind of wrap your head around this properly. And again, I always welcome polar questions. So they're giving me two polar curves. The first equation is r is equal to 4. That means that the radius is always 4 no matter what the theta is from the pole, right? So this would be r is equal to 4. The other equation or curve is r is equal to 3 plus 2 cosine theta. So we'll get to that in a second. They're telling us that both of these curves intersect at pi over 3 and 5 pi over 3. So I'm going to draw in the segment that creates this ray from what? 60 degrees from the initial ray 0, so or pi over 3 rads. And I'm going to kind of mark this up as theta is equal to pi over 3. Then I'm going to go here and I'm going to show the intersection when my theta is 5 pi over 3. Which, if you think about it, it's going to be what? 60 degrees short of going around 2 pi rads, or pi over 3 short of going around 2 pi rads. I don't know. I always can, the way I learned it is go back between the degrees and the rads. But I'm not afraid of the fractions either. So that's 5 pi over 3. So those are my two intersection points, here and here. Now here's the important piece, and this is what I always tell my students. Like, understand how this thing's being built. So you always want to start with your theta. Now, I don't need to look at what r is equal to 4 is. We know the r is equal to 4 is this circle that's going around here. We need to figure out this dimpled situation here on this curve, and I can't remember what these curves are called. But there is a whole library of these things that I'm sure you could look up and search for them. But let's put the 3 plus the 2 cosine theta here. So that's the other curve. Now remember, I'm just going to look and see how this thing's being built. So if I start at theta is equal to 0, right? That gives me what? 3 plus 2 times 1 would be 5. So if you go over 1, 2, 3, 4, 5, on the initial ray, that's where this curve is starting. Now I'm going to skip a space, and I'm going to go to pi over 2. Now when I go to pi over 2, that gives me what? 3 plus 2 times 0 is just 3. So when I'm 90 degrees from the initial ray, when I'm at pi over 2 for theta, you can see that this is 3. And I'm going to throw in pi over 3, just because we know that's where that intersects. And again, I'm not putting the r is equal to 4 in here because you already know the radius is always 4 for that circle. So if I put in pi over 3, this becomes 3 plus 2. Now, you got to think about this. Now, what is adjacent, right, to 60 degrees? The adjacent leg would be 1, right? And then the hypotenuse would be 2, so that would be a half. So the cosine of pi over 3 is a half. So that becomes 3 plus 1, which is equal to 4. But doesn't that make sense why they intersect at pi over 3? Because this radius is always 4, and then that means the radius at pi over 3 for this curve is also 4. And we can kind of prove it otherwise. I would just, one more for good measure, let's look at pi, or 180 degrees. If I plug in pi, that gives me what? 3 plus 2, all times a negative 1, which is 1. So this is where this dimple is created here. And we could go to 3 pi over 2 and then back. But again, I always like to see how this thing's being built, because I think if you know how it's being built, it's a lot easier to kind of break this thing down. All right, so let's see what they want in the first part. Let R be the shaded region that is inside the graph of R is equal to 4, and also outside the graph of R is equal to 3 plus 2 cosine theta as shown in the figure. Write an expression involving an integral for the area of R. Now remember, we don't have a calculator. So my thought is, all right, do you know the fundamentals of doing polar area? Now there's 2 curves, right? So we know they gave us the intersections, so we don't even have to do much math here. So we know that we want to get the area of this as we swing pi over 3 all the way and accumulate all the way back over here to 5 pi over 3. But we then want to subtract the radius squared of this dimpled curve here, just this piece in here, because if we only use the R is equal to 4, that's going to fill in all the way into this opening here, and we don't want that. So the area would be, remember, it's half times the integral from alpha to beta, but in this case, that's going to be pi over 3 to 5 pi over 3. And then I'm going to put a big parenthesis here because I need radius squared minus radius squared. This isn't like area between curves where you go top minus bottom or right minus left, depending on how you're accumulating. But the first radius, or the biggest radius, is going to be my 4 squared. Now what we need to do is we need to wash out this piece here, squared, in order to get the shaded region R. So this becomes 3 plus 2 cosine theta. This is quantity squared, and then d theta. Again, I welcome these type of questions. Find the slope of the line tangent to the graph of the dimpled one at theta is equal to pi over 2. All right. So what are the fundamentals to go from polar to rectangular, right? You got x equals and y equals, right? We need to put it back into rectangular. So to do that, we know x is equal to r cosine theta. So let's substitute the r there. So that would be, the x component would be 3 plus 2 cosine theta. All times cosine theta. So r cosine theta. My y is going to be r sine theta. That'll be 2 plus cosine theta all times sine theta. All right, so I'm ready to roll, right? We got to do a little balancing act here. It's kind of like dealing with parametric. dy d theta divided by dx d theta is how I'm going to get my dy dx. Now be careful. I've seen myself do this before. I've seen my students do this before. You got to do dy d theta first. That's needs to go top, dx d theta on the bottom. Don't switch those. Make sure you're thinking straight when you're doing this. All right, so let's do the product rule, right? Be careful. You always know, though, when you're doing the derivative in polar that you got to use the product rule. All right, so the derivative of this would be a negative 2 sine theta. The parenthesis, all times the sine theta, plus the derivative of the sine theta is cosine theta, all times the r, which is 3 plus 2 cosine theta. Slouching in my chair, I don't know why. All right, same thing for the dx d theta. Derivative of the r is still going to be negative 2 sine theta. Then I'm going to multiply that by the cosine theta. Then I'm going to add that times the derivative of the cosine theta, all back times the r. Apologize, my handwriting doesn't look as neat as it normally does. All right, I want to plug in pi over 2. I don't really have... I would put a plug line over to the right here and then just put theta is equal to pi over 2. For some reason, I wasn't focusing on how I was writing this in. So plug line, theta equals pi over 2. Anytime you have a sine of pi over 2, it's 0, right? Or I'm sorry, cosine of pi over 2, it's 0. So this would be 0 here. So 0 times anything is 0, so that wipes out. Same thing here. I have a cosine theta by itself multiplying to this. This would be 0, so this would wipe out. So what I would be left with is negative 2 times 1, which is negative 2. So, and again, I can show this out a little more. Negative 2 times 1 up top, plugging in pi over 2. That gives me a negative 1, negative sine of pi over 2, all times 3 plus 0. So the answer to this would be 2/3. And again, this is really fundamental, right? This year they just fundamental derivative area perfect, all right? And a lot of times they might go distance between two curves too, maybe find the greatest distance, do some calculus that way, but ain't nothing you can't figure out. All right, a particle moves along the portion of the curve, r is equal to 3 plus cosine theta in the first quadrant. So it's just moving along the curve from here to here. All right, the particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. Well, remember, it's polar, so the distance from the curve is always to the pole, right, or the origin. So they're telling me that my dr dt, you know this is a related rate, is a positive 3 units per second. Find the rate at which the angle theta is changing with respect to time when the position of the particle is at theta is equal to pi over 3. Another one of your typical reference angles in trig. All right, first things first, they do want us to integrate units of measure too, so we know that's going to be in radians per second, just to organize my thought. All right, let's rewrite my r. This is a very simple question. I mean, if you focus enough on a lot of these FRQs and go over them with me or whoever, your teacher, you should see that they always like to throw in some implicit differentiation or related rates problems and different types of questions, just because you're looking at permanent mathematical relationships, and you can do that with that kind of stuff. All right, so let's implicitly take the derivative of this equation with respect to time, dr dt, that would be 0. I would chain out d theta dt. I always like to pull out my derivatives for chain inside out. And then that would be times negative 2 sine of theta. So that's how you would implicitly take the derivative of that. Just plug in what you know. That would be 3. I'm trying to find my d theta dt. This would give me what? Negative 2. Now, what's sine of 60 degrees? I mean, just picture a right triangle in your head. What's opposite of the 60 degrees? It's root 3. What's the hypotenuse of a 30, 60, 90? It's 2. So this would be root 3 over 2. So be careful with your all students take calculus, what quadrant you're in. So this would wipe out to a negative root 3. So you would get d theta dt is equal to 3 divided by root 3. But if I rationalized this, right? I would multiply top and bottom by root 3, which would be 3 root 3 over 3, which just becomes, oh, I forgot the negative, sorry, which becomes a negative root 3. I'm talking, not looking. All right, and then remember, make sure you indicate your units of measure. Just double check and make sure you read what they're asking for, and that's in rads per second. I would have liked this one. I think this is pretty straightforward. I think there's a lot of points to be had with this. Hopefully this helps you.